Okay, well, let's see. I've got 11:01. So again, welcome and thanks for coming. If you have something to say or a question, just feel free to speak up. This is Saturday, July 15th. This is our second session. We're going to look at, we're going to get more into the characteristics of numeric and string variables and how you can manipulate them and how you deal with them. First, though, let's take a look at the assignment, actually exercise. I'm not sure if you people had a chance to try and do this. It wasn't too difficult. How many people gave it a go?
Yep, I did.
Okay.
I did.
Okay.
Yep, I did.
Okay.
Me
What-
too.
Good. Okay.
Yeah,
All right. Well, really pretty simple. This was my solution. Of course, there's a number of ways, a large number of ways that you can do this. Mine looks something like this. So the idea was just to have the user enter.
9 runs.
If it runs, that's always good. Have the user enter their name, and then you capture that in a variable, which I do up here in this statement. I use input. And of course, as we discussed previously, input always returns text. So if you want somebody to enter a number, you've got to nest input inside a different function. We'll look at that today. Captures it as my name, and then you print it back out. Here are two alternative ways you can print it out. So the name that is entered at the keyboard will be captured in this variable. You can just use a print statement, which some people like. And again, it's really just a matter of style. I think that people begin programming just using certain conventions, and they just keep doing that. I prefer the F statement because I think it's easier to use. You don't have to use print to use an F statement. You can use it to define other string variables without print, as we'll see today, I think. But so two ways you could do it. You could just say, please, you could say print, and you could have F, and then you have one big string here, and you capture anything that's a variable you put inside of braces, which I call the squigglies. You don't have to use commas. The other way to do it, I think, is more cumbersome, where you have to separate. Using print, you have to separate each variable with a comma. So this is a in-program variable, but this is a string that you're defining on the fly here. But anyway, if you run this thing, it should work just like this output here. It should look something like this. And so say run. And you enter somebody's name. And day of the month, we'll say it's 03 January. Put this keyboard up on some paper. See if I can make it a little more quiet. And whatever year you want, 1999. And it does some really primitive formatting, no comma or anything, but it puts the month before the day before the year, and then gives you this ending statement, again, with a banner at the top and the bottom, which should look just like this. Now, one thing, so if you look here at the bottom where I print the stuff out, when I print the message out, and there are more than two variables, right? Using the print up here without the F string, you've got just two variables. You got my name and you've got this string, okay, which works really well. But when you have more than that down here, if you use just the traditional conventional print statement without an F string, you have this variable, then you have then you have this, you have three variables, I guess. You have this. Here, let's see if this works. Okay, so yeah, we'll comment this other one out. What I wanted to do was a comment. Can we save this? Yeah, make it big so we can see it all. Day of the month to March 1. To get this to work using the print statement, this is the point I'm trying to make. You have to, because it automatically, the default separator value for print is actually a space. Unless you change that value, it's impossible or difficult to get this exclamation point right up against the end of the sentence, as you see over here. So in order to get it to work right using just print, you have to mess around with the separator, the default separator value. Now, so what's wrong with that? Well, nothing, but it's kind of a hassle. This augurs for my argument that in the long run, it's easier to use F statements with print because they're less messy and you can get as many spaces in anywhere you want, even in between arguments without any problem. Okay, so that's the only point I was trying to make there now. So let's go on and here, let's see, I can make these big. Okay, so let's do some more stuff with numeric data. And so we're going to begin looking in this chapter at writing complete Python programs that retrieve input and then process it, do something to it, and display output. In that first assignment or exercise, there really was no processing per se. And with numeric data, you're going to be crunching numbers all the time when you program in Python or any language for that matter. So as you do with other programming languages, you have these arithmetic operators in Python, and they're similar. They're similar to R for sure. I can't speak to a lot of previous languages, a lot of languages, programming languages that preceded the 2000s. But I'm sure you're familiar. So plus is adding, this is a hyphen actually. It's not a minus. You could call it a minus, but it's also a hyphen. Subtraction, the little asterisk, multiplication, division. This is integer division. And what this does, as we'll see in an example, I think on the next slide, it truncates the remainder. So if you have a remainder in a division, it leaves that off and it just gives you I forget what it's called, the number except for the remainder. And this does this is the mirror image of that. This modulo just returns the remainder. And then exponentiation, you have this. Okay, so these are called operators. And then the numbers on both sides of them would be the operands. So here's some quick examples, right? 5, and the spaces are ignored, by the way. You could type this as 5 plus 4 with no space and get the same result. 25 divided by 4, it's 6 1/4, right? Notice that. And then the integer division, 25 with two division signs, lops off, truncates the remainder, so you just get 6. Note, and this is just kind of an aside or a point that's you should pay attention to. When you do the modulo, which returns the remainder, it doesn't return 1/4. It doesn't return 0.25. Because if you're doing this long division, right, you're dividing 4 into 25, like they taught you in the third grade, you'll have a remainder of 1, not 1/4. So that's what gets returned. And then this is 3 raised to the second power, or 3 squared. 3 times 3 is 9. You can also do 3 to the 1/2, which would take the square root of it. And of course, you can do all of these. You can do all of these directly in the shell itself if you want to. I could say 3. I don't know what the square root of 3 is, but we're going to find out. It's this big long number. So again, spaces are immaterial. 4 plus 5. I don't like typing spaces. Most people don't. It's an extra effort. So those are pretty simple. Now, what else can we say? Well, there's an order of precedence. Okay, so generally it does things left to right, with some exceptions. It will parse your string, the line, and it will look for exponentiation first. And if you have a long expression where you have pluses and minuses, and then somewhere near the end you have exponentiation, it will look for that first. Okay, and then it looks for multiplication, division, the integer division, and the modulo next. And then only after that will it actually look for and perform the pluses and minuses. Okay, so of course, this is kind of, it's hard to internalize and to get to the point where you just recognize this immediately. But this is the order of precedence in which the operators are performed first. So it'll perform this first, and then this, and then these, and then this. The way to get around this is just to use parentheses everywhere, even if you don't need parentheses to get the correct result. Parentheses not only serve to override and change the order of precedence, but they help the user, the person who's looking at the code, understand what's going on. Okay, in some cases, it does make a difference, of course. If you do this, slide here, it's way down here. And it comes out on the bottom. Okay, that's fine. If you do this, right, it's 3 plus 4 is 12. No, I'm sorry. This goes first. So it's 4 times 5 is 20. And then you add 3 to it. So you get a 23. If you want to change it, you can put parentheses here between the 3 and the 4, which will force this to execute first. So you'll get 7 times 5, you get 35. So you get a different result. Again, my suggestion would just be to, whenever you have an expression that is complicated enough to be ambiguous in any way, use parentheses. It serves 2 purposes. One, to change the order of precedence, but also so somebody looking at it can immediately figure it out. Okay, so this stuff is pretty simple, really. And let's see. So this next slide, we've got some code examples, and I have this. We have this on in one of your snippets of script. This thing keeps getting away. If we call up, let's drill down into your materials file.